Pat came, of course, with Howard and is now emeritus professor here at the University of Saskatchewan. She's also a research professor, or research scientist in the School of Geographical Sciences and Urban Planning at Arizona State University, where she was a professor for many years. Pat has won many accolades in socio-hydrology. She's a fellow of the AAAS. She holds the Prince Sultan Abdulaziz International Water Prize. And she has a new book coming out, in fact, this month, Building Resilience to Uncertain Water Futures. This is a Macmillan Press book. I don't know if they'll be for sale in the hall, Pat, but they should be if they're not. Anyway, it's really a pleasure and a delight to introduce a friend and colleague, Pat Gober. Her talk today, if we can pull it up, is focused on integrating the human dimension in water science. Pat.
I thought I would use my prerogative, my family prerogative here, to say that Howard has been a great supporter of sociohydrology, has a deep interest in the integration of social science into water research, that Howard and I spend a great deal of time mixing business with pleasure, talk, our work, our family, our social lives are all deeply embedded in water, but the one place on earth where that is not true, and the place where Howard is the happiest is on his boat in Turkey. So I thought I would start you off with that image. On to more serious topic. I think this paper in hydrology in 2008, Millie et al., talking about the non-stationarity of hydrologic systems, had a huge impact on the field of hydrology. We began to think about what non-stationarity means for hydrologic systems. I think this paper had a huge impact on social scientists interested in water as well, because non-stationarity had implications for the human use and the human intervention with water systems. And that really is going to be the centerpiece of what I want to talk about today. And I thank Jeff for giving a pitch for my book, but I've been spending the last year, and poor Howard has the missed meals to attest to the fact that I've been engaged in finishing my book, really talking about what non-stationarity means to the management of global water systems. And I anticipate, and this is really what I've been thinking about for the last year, and this is coming out at the end of this month. I'd like to talk about three general themes within this social science associated with non-stationarity. First, I'd like to use the issue of water demand. You guys are really interested in water supply. Social scientists are more interested in the other side of the equation, the water demand, which is driven by human use, the economy, human values. There's profound uncertainties associated with urban water demand, where my research has been most highly focused. And I think those are of significance to the principle of non-stationarity. I think there's also tremendous potential to incorporate policy variables. I spent 5 years in the School of Public Policy here at the U of S, and I learned more about policy than I had known before, having been a geographer by training. And I think there's tremendous potential to link policy interventions into the hydrology variables that we have, but we know surprisingly little about the impact of those policies on the behavior of the systems. And it's a challenge for the social scientists to begin to unravel those. And finally, I think that we're engaged in modeling here, and we're also very strongly involved in water modeling in central Arizona, where I come from. And I think that there are some social processes that surround that water modeling. Those of you who attended last night's talk, I think saw some of the social processes that involve the sharing of our science with people in the community. And therein lie some important topics for social scientists to contribute to the non-stationarity of hydrologic systems. So I'd like to talk about specifically about scenario planning, knowledge mobilization, and social learning. So this is my take on non-stationarity. Starting with water demand. If you look anywhere in North America, the trends in urban water demand would look pretty much the way they look in Phoenix, steadily declining over the last 20 years, steady decline in per capita water consumption at the household level. And I think after there's a growing recognition that this is a result of the 1992 Federal Energy Policy Act, which mandated high-efficiency appliances and fixtures in new American homes and the retrofit of existing homes. And that has had a very slow and gradual impact on resulting in a decline in per capita water use. This has allowed many cities to grow in population by 20 and 30%, despite the fact that they have not had to increase their water supply. What I think we're beginning to see, however, is this trend is likely to come to an end. Because what has happened is that we've brought per capita indoor household use down to pretty close to as low as it's going to be. The new frontier for decreasing residential water use is outdoors. It's in the 30, 40, or 50% of residential water that's being used for lawns and gardens and pools. And what I would submit to you is that that is very much the result. That's not a technological issue that can be fixed with toilets and better dishwashers, but rather by a change in attitudes and behaviors about how we want to live and how we want to maintain our gardens outdoors. I can tell you there's very little known at this time about the determinants of outdoor use. I think California, if I can remember these statistics, a study of California communities in recent years has given us some indication of what a knotty problem this is going to be. 82% of households use outdoor water, and again, it can amount to 30, 40, or 50% of the total residential use. 82% are watering outdoors. 52% are watering in excess. That means they're using more than evaporation would require them to use to maintain those pools and gardens. And here's the kicker. 15% of households are using 62% of the excess water. So it's a very highly targeted problem. It's specific to neighborhoods, it's specific to people, it's specific to behavior. And this is the uncertainty associated with further declines in outdoor water use. How effectively are we going to be able to tackle that question of outdoor water use? Because we know very little about it now. I'm so happy that one of my colleagues, Murray Fulton, is sitting here because he and a graduate student of mine in the School of Public Policy had an idea to understand the sensitivity, the responsiveness of urban population to conservation signals. So we had a water emergency in Saskatoon in the summer of 2011, a breakdown of a filtration plant. It was a natural experiment. So we went back and collected data and looked at the use on a household basis over time. And we, and asking whether that event in 2011 resulted in significant reductions in household use. We reduced use by about 17%. in that particular event. But what we saw was tremendous variation from neighborhood to neighborhood in terms of their responsiveness to the city's signals to, we need you to conserve your water. We need you not to use any water on Monday, Wednesdays, and Fridays, so we can forego the need for a new, for new infrastructure. But we began to get an understanding of what a behavioral issue this was and how difficult it is to get. And there's not a simple technological fix to the decline in outdoor water use. Price is also a mechanism by which we can alter the outdoor water use. But some of you may have already seen this. This is one of my favorite diagrams. This is the pricing structure, but communities have very different pricing structures depending on their values. Their values about water, their values about equality, their values about how they want to distribute the cost of water provision across their population. And you're looking at the water rates in Phoenix as compared to Tucson, Arizona. The blue, gray, the horizontal strips represent Phoenix. You pay according to how much you use. That's the cultural ethic in Phoenix about how water is valued. In Tucson, on the other hand, at very small uses, you're going to use very little, the price is going to be very low. So we make indoor water essentially free to the population. And then as we move to higher use rates, water becomes extremely expensive. So it's a different pricing system that reflects different community values. And so we're going to have, these are factors that we're going to have to consider when we look at the responsiveness of water use to varying policy signals. Phoenix is on the left, typical, I call it an oasis city, and Tucson is a desert city on the right. I've also spent a lot of time building this model, and some of you have seen, it's called WaterSim, and it's a way we simulate the future water supply and demand conditions in central Arizona. But what has become increasingly obvious to me over time is that the model is interesting, and the model represents the water situation in central Arizona, but the interface is really key to the way we message this model. So when we first took a look at WaterSim, this is maybe 10 years old, 10 years ago, we really emphasized the climate change impacts of it. We talked about what the uncertainty of climate meant for the water supply and the potential growth prospects of Phoenix, Arizona. People told us, our water managers came to look at our interface, and they said, we're not interested in that. There's nothing we can do about that. Why don't you show us the policy levers that we can pull to alter the future that we already know is uncertain? So after about 7 or 8 years, we replaced our interface with one that emphasizes across the top different sustainability outcomes, and down the left side different policy choices, policy levers that people could manipulate to see what the impact of those policies would be on the long-term future of central Arizona. I think there's a social science associated with the interfaces connected to the models that we build to represent how we deal with an uncertain future. I think there's some social processes associated with decision-making under uncertainty. Non-stationarity puts us into a situation where we don't know what the future is going to be, but what kind of decisions can we make to live with uncertainty, make the best decisions we can in spite of uncertainty? We created we did some scenario planning in Phoenix using some of the policies, growth management, conservation, and we we use them to figure out how would modern Phoenix fare if we had another medieval drought. There were very difficult climate conditions in central Arizona in the 1200s. What if we were to repeat those in the next 50 or 100 years? What tools do we have available, and what is the sensitivity of the water system to those tools? So we've spent a lot of time with this kind of an analysis of scenario planning. I can tell you scenario planning has been very important in Las Vegas. How do we plan for an uncertain future? And to make Vegas is very much unnerved by those bathtub rings in Lake Mead, because they represent the level at which lake levels that have fallen over time. Scenario planning in Mead took a look at the blue lines, the water levels in the lake and how they've changed over time, and those red lines on the side are the intake valves for the city of Las Vegas. And in one of its recent scenario building exercises, the population declared it unacceptable to have intake valves at 1,150 and 1,000 feet. The climate, with the prospect of climate change that you could see in the lake levels, and certainly had been noticed that these were not going to come, that they had to build a new intake valve at 500 square feet. The importance of social learning. And for social learning, they're nice. We hope to gain buy-in from our local population for the science that we do. We want to share the science. We want to build capacity for decision-making under uncertainty. But let me tell you, for social scientists who are interested in non-stationarity, these are research questions for us. Those interfaces are research questions for us. The experiment last night becomes a research question for us to produce best practices for how we can promulgate the kind of social learning that took place last night and takes place in activities like that. And so, one more picture. Howard and I went to Chile and continued our relaxation exercises in November. But stationarity is dead for social scientists too. So we're learning to decision make under uncertainty, not to predict the future and not to optimize the future. I think we have an unprecedented potential to contribute to the policy analysis. We have to know how sensitive human behavior is to these myriad policies that we're talking about to respond to climate change, and we don't know very much at this point. It's a very important area of future research for us. I don't think you should pigeonhole social science. My pet peeve is when you pigeonhole social scientists as the knowledge mobilization people. It is a process. We're interested in the process. We want to engage in the process, but this is a research question for us. And that's enough. Thank you for your attention.